Let's start with the today's session. Uh, till now, we have seen up to third unit, and from the third unit, we have seen exception handling. Then the throwable base class and user-defined exception class, checked, unchecked exception, finally block, nested try, chaining, the try and catch block. That all we have seen. Right. Today's session, we are going to see IO, input and output. Now, if you see the syllabus, you will find that the IO typically starts with the dealing with the disk data in terms of file. But when we say IO, we should not conceal ourselves with the thought process of it's just regarding the file handling, input and output. No, the classes that we will learn right now will help us in dealing with any device that can be attached to your computer. Like you will be, once we have a good hand-on input and output technique and classes, we will be able to send and receive data to any device, and we will be able to receive a data from any device. For example, input and output, if we are able to send and receive a data from a file, in the same way, we are able to send and receive the data from disk, as well as network drive, as well as, let's say, you have any printer attached. Then if you are communicating with any device, this thing will fall under the category of IO, right? So let's understand some basics of IO, and then we'll write the first program. Is screen visible to everyone? Great. Let me open up a paint. Now we will assume that, let's say there is a device 1 and there is a device 2. Device could be anything. Device could be anything, right? So let's not consider that one is in a, let's say the computer program and the other device is a disk. No, we will just assume that there are two devices, right? And devices could be anything, any components that can interact with each other. Right now, we are not worried about the protocols they will be using if they want to interact with each other. We just assume that these two devices can interact with each other. Now, in these terms, if we put a, let's say, there is this connection between these two devices, right? And between this connection, the data is flowing. Let's say 0, 1, 0, 0, 1, 0. Now, when this data is flowing, let's say this is a device A, and let's say this is device B. And when the data is flowing between the device A and B, we can see that data is getting transferred in terms of bits, zeros and ones. Now, this zeros and ones, we call it as a stream. Now, stream is a very generalized word, can be used to precise or can be used to describe anything which is traveling in a group manner or in a bunch manner, right? So when we are saying that 0, 1, 0, 1, and a continuous flow of 0 and 1 is going from one device to the other device, we refer this flow of 0 and 1 between two devices as a stream, right? So you will astonishingly find that the base class of anything, if you want to do any kind of IO, the base class in Java is called as stream. If we are sending a stream, then it is called as a output stream. And if we are receiving a stream, we will call it as a input stream. Now let's assume that here we are sending data from A to B, A to B. In this case, device A will be using a base class in Java called as output stream, right? Because A is sending the data. So A will be using a class in the Java, base class in the Java called as output stream. And as B is receiving, B will be using its counterpart. We will call that as input stream, right? So remember, whenever you are sending a data directly, indirectly, somehow, Doesn't matter which class you are using, you are dealing with output stream. And if you are reading the data, doesn't matter from which device, how, which classes you are using, indirectly, directly, you are going to the input stream class of Java. So we will always keep that in mind, right? And again, these both classes are said to be inheriting from stream. So both are streams like zeros and ones, right? Any doubt in this point, in this discussion? Anyone have a doubt? Okay, great. So let's continue with the discussion. Great. So now this data could be binary or a character data. Now here we have to clearly understand what I really mean. So let me open up a notepad file to explain what I really want to say. So let's say this is a notepad document, and now I'll type a number in this notepad document. The number is, let's say, 1234, right? So when I save this notepad document in my document folder in the computer, that time this 1, 2, 3, 4, these are all separate 4 characters, and your computer is going to store these all 4 characters in a individual way, right? All the 4 characters will be stored separately. But as a human being, you may want to read this data as 1234. Or if I put this, let's say I'm writing a computer program, assume this becomes a computer program, and I declare an integer I variable, and I say 1234. Now, by assuming that this integer I will be requiring 2 bytes, we are assuming this data size. If we assume that this integer variable requires 2 bytes of data, then this 1234 entire data will be stored. This 1234 information will be stored in the 2 bytes format, right? But I assume this data to be a character data. If I assume this data to be a character data, let's say character C, and it becomes array. Now, if we know that we can store only one character in a character variable. So I definitely need a character array if I want to store this all 4 characters. And in this case, if I say this is a character array, if this is a character array, and if we define this character array, if I say 1, 2, 3, 4, then this character array have 4 locations, Now, the information is very same. The information that we are storing is very same. Like we are storing 4 digits, which are 1, 2, 3, 4. When we are using a numeric type of variable, that time my memory requirement is just 2 bytes. Assuming that integer data type in Java is going to take only 2 bytes, right? Now, its counterpart, which is a character array, to store the same number of digits that are 1, 2, 3, 4, is going to take now 4 bytes. Assuming that a character data takes 1 byte to store 1 character, right? So we want to store 4 characters, so it's going to need 4 bytes of memory. Now, if we write this information on the disk, how many bytes will get returned on the drive? If we are writing the character array, is like disk requirement is of 4 bytes. And if I write this as an integer type, is disk requirement is of only 2 bytes? So that is a really question that programmers has to deal, right? Now, let's say that we have 2 types of information. Okay, before continuing, anyone have a doubt in this? You can raise your hand, or you can post it simply in the chat box if anyone have a doubt till the point, whatever we have discussed. Okay, great. So no doubts. I hope that all the concepts that we have discussed are clear to you. Okay, let me go to this file and save option. So focus on this. You can see here there is one tab called as encoding, and in the encoding it is saying UTF-8. It does mean UTF stands for Unicode Text Format, and that -8 indicates that I'll be using, or not I, the Notepad will be using 8-bit size for representing one character, right? Now, if I click on this, you will find that all the different set of character set that are available in which we can write the data. Here you can see that the very famous ANSI, like if I select this one, again, I'll be using the ANSI format, or the, I hope you are aware also about ASCII format, American Standard for Code for Information Exchange, right? So these all formats will be compatible. Like say, if I use a ASCII format while writing the data, if I, let's say, use ASCII format while writing the data, and ASCII format says that I'll be using one byte per character. Then while reading the data from the file, we are again have to take care that we will be reading 8 bits at a time. That is 1 byte at a time. Let me create a scenario. Now assume this is a disk representation of the data that you have written. I'm using 1, 2 as a wrong thing. Now see, this all information is of group of 8 characters, right? So this is the first information. Then I'm using a space to indicate a second information. Then this is the second character. Then this is the third character. Then we have the fourth character, and then we have a fifth character. So we are right now, my disk is representing 5 characters. Let's say that this information is stored in a sequential manner, and let me remove this space in between all 8-digit characters, right? Now this is the data. Now let's say that the one who stored the data assumes that you will be reading group of 8 bits at a time. So this represents, this information reads one character. Now if the person who is reading this information, let's say, uses 2 bytes as in a single character, then what that person will do is 1, 2, 3, 4, 5, 6, 7, 8, and here is the first character completed. So 1, 2, 3, 4, 5, 6, 7, 8. The second person will read this much information, that is total 16 digits from your file, and the person will try to understand that 16 digits as a single character. Now here the meaning of the information is going to change, because the value, let's say you were representing 1 using 8 bits. Now if I using the 16-bit encoding, the value of 1 and let's say the second digit is 2 is going to change, and some higher number from the decimal family will appear on the screen. So this sync between the person who is writing the data and the one who is reading the data is very necessary. Now, if we replace this terminology of person who is writing and reading the data from, in the terms of programs, the program which writes the data and the program which reads the data, we have to understand, we now clearly understand that the program which is used to write the data on the disk and the program which is used to read the data from the disk has to use the same encoding. If this encoding gets mismatched, then the information which is written on the disk and the information which will be read from the disk will be totally different. Now, I will promise one thing here, that I will show you that I will write English characters on the disk and I will read it as a Chinese characters or the Japanese characters, right? Even we will convert this into the cards characters like piece or maybe a heart shape or maybe like any card from your cards game, right? So we'll use this. What we will do is we will simply use one encoding scheme while writing the data on the disk, and while reading the data from the disk, we will use a different encoding scheme. Just by making a difference between reading and writing mechanism, how many bits we are going to read from a file, the entire information representations will get changed, and we will see that effect. Okay. So as we proceed in this session of IO, we will be able to handle the different coding mechanisms and we will be able to understand if something is going wrong, if the data is getting miswritten, or if the data is getting. Abhishek, you have sent me a request of annotation. Abhishek Doshi. Mr. Abhishek, 831. Abhishek, you have sent me the request second time. So I have to remove Mr. Abhishek because he has sent me 4 requests for annotating the screen. So it's a bit hard. We will talk about maybe his device is having some problem. So I have to remove his device from the meeting. So let's continue. Okay, I've paused now. So if anyone have a doubt, post the doubt in the chat window. Why are you okay? Fine. Anyone have a doubt? Please post the message in chat. The doubt in the chat window. Fine. So now understand that. Let me again put a space between this data 1001411234. So this becomes the 8-bit 1001100101. The second digit 11001111 is the another 11010101. So yeah. So let's say that the information is this, what we have written on the disk, and we assume that we will be reading the information in the character form. Okay, so let's understand the scenario. Now you are sending and receiving the information between 2 devices. This is the first scenario. Now let me extend this board, and now what we have is, let's say this is the disk. On a disk you have written information 0101 0000, a first character, right? And let's say there is also a second character 1111 0000. So there are 2 characters on this disk, right? Now the program one have written this information on the disk. Let's say this is the program 1 which wrote the information on the disk, and there is a program 2 which is going to read the information from the disk. Let's say this program, while writing the information on the disk, used character format, character encoding, char encoding. What it means is that this program is writing 1 character at a time on the disk, right? And we will assume that 1 character is going to take 1 byte. 1 character is going to take 1 byte. Assuming that you are using ASCII encoding or a UTF-8 encoding, 1 character will be taking 8 bits, right? So 1 character will be taking 8 bits, and you are using ASCII or maybe UTF-8 encoding, and your program is writing one character at a time. The program P2, which is on the right side, this right side program P2 is reading a information in a byte format. This program is reading the information 1 byte at a time. 1 byte at a time. Now see, there is a clear difference that this program on the left hand side, let's call this as program A, and the program on the right side, let's call this as program B. The program A has written information in the character encoding, but character encoding has used 8 bits to write the information, right? Character encoding has used 8 bits to write the information. The program B is reading 1 byte at a time. 1 byte at a time. 1 byte means again it will be reading 8 bits at a time. Automatically the sync between program 1 and program 2 will happen here. There will be no reading error. Like program B will read 8 bits, then it will try to convert this into information. Then the program B will read second 8 bits and it will try to convert it into information. And even if the both programs are using different coding style for writing the data and for the reading the data, the sync will be perfect. The sync will be perfect, that you are writing information in the 8-bit format and you are reading information again into the 8-bit format. So even if one has used a character encoding and one is using a byte encoding for reading the data, or byte stream to read the data will be read correctly. The error will start when, let's say, you are using a character encoding while writing the data, but this time for writing the data you have used 16 bits to represent one character. You have used 16 bits to represent one character, right? Now this has been done by program A, and it is now using 16-bit encoding while writing a character. But the program B has not changed, and program B will still use a byte encoding while reading the character from the disk. Now here the error will happen because program B will read first 8 bits as in a single character, and as soon as it reads the first 8 bits as in a single character from the second stream, you can see that the meaning of the information has changed. After reading the first character, the program B will read the second 8 bits as a second character, whereas program A has written this all 16 bits as in a single character on the disk. Now this error we will see practically when we'll see different encoding schemes in which we can write the data on the disk. That time I will practically show you this error happening. Like we will write English character and it will be represented with some Korean, Chinese, or Japanese character set, right? So we will see this. Now, as I was saying that one program is using a character style while writing the data, and one program is using a byte style while reading the data. So why altogether there are two formats in which we can read and write the data in Java? Like one is a character format and one is a byte format. When you will be dealing with simple plain text data, then it is recommended that it's better you should use character encoding, because Java takes care of many things. Like the second scenario that I am saying can be handled automatically without the worry of programmers. So we will see that how to do it. So this character mismatch case will be well handled by character encoding, and we should use character format while reading the data as well as writing the data. So if both the programs who are reading and writing the data are using character encoding, then it is less likely to end up into a error situation or the garbage information situation, right? And if you are reading a byte, like then why altogether byte stream exists? Like, so every information is not a text data. Like for example, you want to transfer a music file, or you want to download a movie file, or you want to download some binary file like a Word document. Word document, don't think it as an text data. Word document have a lot of settings with it. Like for example, you can set up font size, you can set up a color, you can set up a bold, italic, underline, and all the stuff that goes along with the text data is a type setting, and this type setting will be saved in a encoding format along with the data with which it is attached. So when we have a type encoding in the Word file, that time the document no longer becomes a plain text document, it becomes a binary document. So if we want to download a binary file, then in that case, character encoding is not helpful. You have to use byte encoding while dealing with binary data, right? So it is very clear that if we want to deal with the character data, let's deal with the not a character, textual data, then it's better to go with character encoding. If we want to deal with the binary data, it's better to go with byte stream. Also, when you will, like right now we are starting this discussion by assuming that we are interacting with disk. What if you are sending and receiving a data on the network? What if you are sending and receiving the data from a printer? So the bunch of options you have, and you have to prefer that you have to select the choice which kind of encoding you want to use based on what you want to achieve, right? So as we proceed, you will have enough maturity to select the streams available and select the specific class that you really need while dealing with the data. So I'll take a pause again here. Any doubts? Okay, there is one question. No, okay, so that is not a question. No, I is answer. Anyone have a doubt? Please raise hand or we will continue. So if you don't have a doubt, please post the answer as no. We can continue. Can we continue? Okay, good. So snail halki, snail natakle. Okay, snail, we can continue. That's what you want to say, right? Or you have a doubt? Fine. Let me create a file directory called as file IO. I'll go to this directory file IO and let's create a notepad file. I again call it as first.java. Okay, it's a Java file. Now, when you want to deal with the input and output in Java programming, we have to import one package called as java.io, right? I will prefer a star symbol because I can go with the very specific, like saying file input stream and file output stream, a file reader and file writer. Basically, I'm interested in 4 classes. So instead of writing all 4 lines separately, I'll be using the asterisk symbol, a wildcard character, just to import everything that I need. Then I'll make this class public class first. Okay, so let's quickly write the main method. Fine, and let's create a text document using a notepad. Now, I used analogy like there are 2 programs, like program 1 and program 2. One is writing and one is reading. So what we will do is we will use our Java program to write the information and we will use Notepad to display the information, right? So one program is going to write the information and the second program is going to read the information. Or we will do in a reverse way, like we will use Notepad to write the information and we will use a Java program to read the information. In either case, the encoding has to work. And we will assume that this first scenario is true, like the Notepad used 8-bit encoding while writing the data, and Java program also we will use 8-bit encoding while reading the data, right? So let's check whether we are writing characters using Notepad and whether we are reading bytes using a Java program, but the information representation must not change. So let's do it. For that, let me create a document called as a.txt. Okay, and let's call this as this is first text file, and I'll put a dot and I'll save this text file. Now you can see that the character 1, character 2, character 3, character 4, space is also character 5. So there are fifth character. Then we have this bunch of characters in the file. And if I click on save, it has been saved. If I just click on save as, you can see that I'm using 8 bits here, 8 bits to write a single character. So my encoding is of 8 bits, right? So as you understand that I'm using a encoding of 8-bit size. Okay, fine. So file is present. Now we'll go to the program. Now we will try to read the information in the byte format. So we will try to read the information in the byte format. For that, in Java, to read information in a byte format, file input stream is the class. So I'll create an object called as a file, new file input stream, and then let me pass the name of the file, which is a.txt. Now the file is present in the same directory, so I can simply put the name in the double quote and assume that the program will be able to find it. If the file is not in the same directory, you have to include the full path. Okay. Fine. Now let me go back to this. There are no doubts. Now to read the information, like we can go and refer a Java document here. You have to go to the package called as java.io. From that package, you have to find out the class called as file input stream. Once you locate the class, you will see the different constructors which are available against the class file input stream. Like one constructor is an empty parameterized empty constructor. One is an accepting a file name. Another constructor accepts a Boolean flag, whether it is true or false, depending on whether you want to append the data or you don't want to append the data, want to create a fresh file every time. So there are various constructors available. Go and check those constructors. Now there are also different methods available, so using which you can read the information, right? So let me make use of a simple call called as read. Now this call returns an integer information in an integer format. So I'll say integer I is equal to find.read, right? So it's going to send me information now numeric format. So I'll be using a number. See, what I said is we will be reading the information in a byte format, right? So I'm using a integer data to read information, and I'll keep that into a variable called as I. Now let me print this variable on the screen. Println. So I'm printing a number on the screen. I am printing the number on the screen. Let's try to compile the program. Java C first dot Java. Okay, unreported exception, file not found exception must be caught or declared to be thrown. By looking at this, I am sure that you can recall that this exception is of a kind of checked exception, and it warns the programmer that your program may lead into an exception of type file not found. So it's better either you use a try and catch block or make your main method throw this exception. So better what I'll do is I'll put this code into a try and catch block. So this is a good example of checked exception, right? Now the program will compile. Let's try to execute Java first. And we have read only one information. So you can see that 84 is printed on the screen. Now, what is our first character? First character in the file is T, right? So we read only one character from the file. This reads 1 byte from the file. And we are printing this I on the screen. So this 8-bit of T is represented as 84 on the screen. So now let me add a code called as system.out.println. Then I'll use a perform a typecast. Like I want to convert this number into a character format, and let's see what Java does. If I save this, let's also see what we have done. We read the information in the byte format. As it's a byte format, the return type of this read method is of type int. So I stored this value into integer variable I. If I print this I variable directly, it is printing a number. Of course, integer is a numeric type, so it is going to, so it is supposed to represent a number on the screen. So it printed a number. Now, character is a type conversion from integer value to the character value. So we have saved the file. Let's go to the notepad. Let me clear the screen. Now, Java C, first.java, Java first. Can you see the T has been printed on the screen? So it is reading from a file, and now if I perform a typecast, it is printing T on the screen. After the catch block, what we can do is integer k is equal to 84 system.out.println character k. Now if I compile and run, I hope you can see there is a second T on the screen, right? So clearly see the wonderful part here that Notepad is using UTF-8 encoding while writing the data. Your Java program is using byte encoding while reading the data, because we are using file input stream class, and this file input stream class use byte encoding, right? Byte encoding mechanism while dealing with reading or writing. Now we are using file input stream, means we are reading a byte information from a file. And even if the both encoding mechanisms are different, Java have handled the case very efficiently. Like, why I'm saying Java handled the case very efficiently, because both programs are reading 1 byte at a time, even if the encoding mechanism is different. It is a byte encoding, it is a UTF-8 encoding, but both formats are using 8-bit of 8 bits to represent a character. So both programs are in sync. So this first scenario has been satisfied. Like A used a character encoding but used 8-bit format. The program B used a byte encoding but again used the 8-bit format, and the information is read correctly, right? So this happened. Now let's still we have read only one character. Let's read the complete file from the disk. Now there is a special code in Java. When we use this read operation, we can put this in infinite loop. Like I can say I is equal to affine dot read, and this code will run infinitely, right? This code will run infinitely. As soon as you hit end of the file, the program will crash. Now what we can do is system.out.print. Instead of print and go to the next line, I'll just use print. So it will print on the same line, right? And here again, let's do the character conversion and let's print I on the screen. And what I will do is I'll just put a comment on earlier read lines and some display output. Also, after the catch block, there is a read and write. So again, I'll put a comment on this also, right? So let me save this. Okay, have I made any mistake? Cannot find symbol I. Okay, great. So let's go to the program file and K type. Here is not equal to -1 represents the end of the file. Again, this is going to go inside I value. So let me correct here. So what is this meaning of this code is read from the disk, read from the file, put the value in the I. The value of I, if it is not equal to -1, go inside the while loop and convert the integer information into character representation and print it on the screen. If this value of this I becomes -1, it means that the file has reached end of file, EOF. So this -1 represents the end of file character. Okay. So we are reading infinitely unless and until we are not hitting the end of file. End of file. So let's start. So let me save this. Let me clear the screen. Java C first dot Java, and now Java first. So you can see this is first text file. The complete file is read, right? So we have read a complete file from the disk. Now what we can add extra information is we can also represent, or we can also print the number associated with each character. Let me print I, and immediately after the I, we are printing, let's take one piece, and then on the next line we are printing. Okay, I've gone to the next line, print ln. I don't want a line. Let's this simple. So now you can see that 84 means T. Okay, we have to add one more space to understand it clearly. So you here 84 means T, 104 is the code for H, 105 is the code for I, 115 is the code for S, 32 is for the space. So this is not a blank thing, it is a character for the space. 105 is for the I. Again, you can see that whenever there is a space in the file, this is the first space, this is the second phase, we can see that the 32 is getting repeated, 32, 32, again 32, so and so on, so on, right? So this is the scenario that you are, what we are doing is we are going to the read call, we are reading a character, sorry, we are reading a byte, we are converting into a character, and then we are displaying it on the screen. Any doubt till the point? Now the floor, okay, the floor is open for, there is one question from my side. There is question from my side. What is the drawback of this program? What is the drawback of this program? Can anyone tell me what is the drawback for this program? Can anyone tell me what is the drawback of this program? Look at this scenario using the paint diagram, whatever we have discussed. What is the real drawback of this program? Can't read the whole file in one go is the answer from Harshit. Okay, any other answer? Okay, the same answer. Okay, fine. Any other answer, or anyone is going to bank on the same answer? Okay. So there is one surprise coming in a moment. a quick poll is coming. Just want to check how many people are truly attentive. So answer the poll. So 27% people say that there is only one, which is a 33% count. How many finite blocks we can have in one program? So 33% people said that we can have only one. 46% people, which is a very good count, that is number of people are 37. They are saying that one for every try. Then few people are saying one for every catch, and then one for every method, and then no answer by 5 people. So the B is the correct answer. We can have as many finally blocks as there are try blocks. For every try, we can have one finally block attached, right? So we have stressed on this point in the last session. So I guess 37 people truly and heard that line what I said. Like we can have one finally block associated with one try block, right? So the people who have marked it as only one, they have read a book or they have read it on the web, which is saying that you can have only one finally block. But the true thing is you can have one finally per try. Okay. So this is the result. So let's go back to the discussion. And what I asked is, how many, what is the drawback of this program? And then Harshit said that can't read the whole file in one go. In fact, that is the drawback. Before proceeding with the answer, let's check out its counterpart. Counterpart is reading a character data from a file. So file reader is the class in Java which reads one character at a time from the file. And it uses Unicode encoding. Now let me use again the same file. So instead of fine, again I'll use your for. So I'll just put a comment on the file input stream, and instead of that we have file reader class, right? Let me save the file. Let me recompile the program and execute it. So you can see that there is no difference in the execution whether we are using a file input stream or we are using a file reader. The key difference is the file reader is using character encoding and file input stream is using byte encoding. So one is a character reader, one is a byte reader. Keep that in mind. Now let's come back to the point. What is the drawback? It is not reading the entire file in one go. So we are referring this in very simple way, like, okay, my program is reading one character at a time. Now let's understand truly what is the effect of this program on my computer. So when this while entered, while as soon as the while block entered, you have a call find.read, find.read. So as soon as this read entered, one thing happened. The thing is, so this is a disk. Let's say you have a disk. On this hard drive, you have a magnetic plate, and there is arm which is actually reading from this magnetic plate. And this is your, let's say there is a main memory on your computer. Let's say this is the main memory on your computer chip, and the data transfer is happening between you are reading from a disk. So I have to use a reverse arrow. You have to read from a disk. Okay, fine. So I need both arrows. So you are sending a request to read, and disk is sending back the data which you have requested. So let's see what happens. Let me open up the text file. So what your program does is it sends a request that it wants to read a data. Now it wants to read a T. So your program, which is here somewhere, running program, sends a request to the computer. The request has been received by the computer. As soon as your program sends a request, computer checks whether that information is present in the main memory or not. As soon as the main memory, which is this one, main memory, as soon as this main memory finds that the data is not present inside it, the main memory, the computer takes the action. It sends a read request to the hardware. Now, which is the hardware? This is the disk. As soon as the disk receives the read request, this arm has to move. This arm performs a read operation, right? So this arm rotates on this disk. Arm rotates on the disk. It rotates on the disk to read the information from the tracks. It reads that character, again gets parked into the null position, and that character is returned to the main memory, and from main memory to the program, right? So one character is read. Now your program wants H, the second character. So again, it checks the character is not present. Again, the computer initiates a read request. Again, it is sent to the ARM. Again, the disk movement happens. Again, the character is read. That character comes back to the main memory, from the main memory to program. Now your program wants the third character. Again, entire loop. So this loop is going to repeat. How many characters we have in the program? Let's count that also. Let's see how many characters we have in the program. So let me put a count. CNT is equal to 0. And every time my while loop enters, I will increment this CNT plus plus. And after the while completes, let's print the count. Out println CNT. So let's compile this. Okay, what is wrong? Okay, println. Now let's print the count. Now you can see that the count is 24. So there are 24 characters in my file. 24 characters in my file. So 24 times the disk has been opened and the arm is moved, and 24 times the character is returned. So every time you want to read a character, your program is sending a request to the main memory. There is character is not found. Again, it goes to the hardware, to the disk. disk R movement happened. It reads one character, it returns to the computer, computer sends it to the program, closes the hard drive. The read after the hard drive read operation is done, that particular arm is been closed. Again, you want a second character, the entire process repeats. Now this is fine, just you are sending a 24 character read request. What if your file have 1 lakh characters? 1 lakh characters. So 1 lakh read operations will happen. 1 lakh time your disk will be opened, a single character will be read, returned, disk will be closed. Again, the next time you will again open the disk, read the character, send back to the program, again close the disk. So if you do it for the 1 lakh time, I am sure by the end of the program execution, you need a hard drive replacement. You need a hard drive replacement because hard drive will truly start giving complaints, malfunctioning, or the arm is not doing correct or some other thing, right? So this is the worst program that we can use to read from a disk. And here comes the requirement for something called as buffers. So it is 10.2. We have I think you have a next session of CA. So we will start with something called as a buffers in the next session. Okay. So you can leave the meeting, no problem. Thank you.